All right. So today we will do, first of all, a few questions from this. Because mostly the theory has been covered. Yesterday also we have done inverse of a matrix, how to find the solutions of the equations, and how to solve the equations using determinant method, using matrix method. So we have almost covered the entire syllabus. Now we'll go with few questions. Like this question you see, this is a previous year JEE Mains question. For the system of linear equations, x plus y plus z equals to 6, alpha x plus beta y plus 7z equals to 3. Okay, before I start, see, for three linear equations, I told you x is what? Delta x by delta. Y is what? Delta y by delta. And z is what? Delta z by delta. Now, you will have to tell me, first of all, Rama Aksha. Rama, what is the condition for unique solution? Rama, switch on your mic and speaker. What is the condition for unique solution? Anush, what is condition for unique solution?
Delta is not
Sorry?
equal to delta is not equal to 0.
For unique solution, what did you say? Delta
is not equal to 0.
Not equal to 0. Okay. For infinite solutions, Lakshmi, what is the condition? Vedasri, what is the condition?
Sir, is it delta equal to 0?
As well as delta x equals to delta y equals to delta z equals to 0. Correct? And for no solution, Ranju?
The delta is equals to 0 and at least of one of delta x, delta y and delta z should be non-zero.
One of delta x, delta y or delta z should be non-zero. Correct? Now see, in this equation, you see they are asking for no solution, unique solution, infinitely many solution, and whatever they are asking. So the foremost thing that you have to do, you will have to find delta, delta x, delta y, and delta z. Only then we will be able to conclude it. Like delta is what? Delta is determinant 1, 1, 1, alpha, beta, 7, 1, 2, 3. Correct? Directly I will expand it. That is 1 time 3 beta minus 14 minus 1 time 3 alpha minus 7 plus 1 time 2 alpha minus beta. So it is 3 beta minus 14 minus 3 alpha plus 7 plus 2 alpha minus beta. So it is 2 beta minus alpha minus 7. We will keep it up to this point only as of now, because neither I can factorize this nor I can do anything. So just leave it here only. So it is 2 beta minus alpha minus 7. Correct? Now find delta x. So in delta x, what I will do? In the column of x, I will replace the right side 6, 3, 14. 6, 3, 14. Isn't it? 6, 3, 14, yes. Then 1, beta, 2, 1, 7, 3. So it is 6 times 3 beta minus 14 minus 1 time 9 minus 14 7 ja 98 plus 1 time 6 minus 14 beta. Now it is 18 beta minus 14 6 are 84 plus 89 will come plus 6 minus 14 beta. So this is what 18 beta minus 14 beta, 4 beta minus 6 and 89 minus 84, 5 and just a moment. It is 6 times 3 beta minus 14 minus 1 time 9 minus 98 plus 1 times 6 minus 14 beta. So it is 18 beta minus 14 beta means 4 beta. 84 minus 98 minus 9, 89 plus 6. 89 minus 84 is 5, 6 and 5, 11. 4 beta minus 11. Chalo, whatever it is. Now, similarly, delta y you will have to find. Tell me what is delta y? 1 alpha 1. 6, 3, 14, 1, 7, 3. So it is 1 time 9 minus 98 minus 6 times 3 alpha minus 7 plus 1 time 14 alpha minus 3. Correct. So it is minus 89 minus 18 alpha plus 42 plus 14 alpha minus 3. So it is minus 4 alpha, 89, 92 plus 50 आ जाएगा. 92 minus 92 plus 42 plus 50. Even minus 50. So it will be minus 2 times 2 alpha plus 25. 163, 14. And now finally delta z. Delta z is 1 alpha 1, 1 beta 2, 1 alpha 1, 1 beta 2, 6, 3, 14. 1 alpha 1, 1 beta 2, 6, 3, 14. Now it is 1 time 14 beta minus 6 minus 1 time 14 alpha minus 3 plus 6 times 2 alpha minus beta. This will come. All right. So this is 14 beta minus 6 minus 14 alpha plus 3 plus 12 alpha minus 6 beta. So 14 beta minus 6 beta is 8 beta. 8 beta plus 2 alpha minus 3. 8 beta plus 2 alpha minus 3. Now see, now I will generate the condition. System of equations has a unique solution. Now see, for the unique solution, what do you want? You want, if for unique solution, now what is my delta x? It is 4 beta minus 11. Delta y, it is minus 2 times 2 alpha plus 25. And delta z is 8 beta plus 2 alpha minus 4. 8 beta plus 2 alpha minus 4. Now see, let's go with the option. If alpha equal to beta equal to 7. If alpha beta 7 आ जाए, then definitely delta x is what? Is going to be 0. But delta is going to be 0, but delta x is not going to be 0. So 1, 0 and at least one of them non-zero, the system is having no solution. So this is, they are asking for not true. So this is basically true. Am I correct? Now come to second option. If alpha equal to beta and alpha not equal to 7, then system has a unique solution. See, agar alpha beta same kar do, alpha equals to beta and alpha not equal to 7. So definitely this is not going to be 0. If this is not going to be 0, that means the system is going to have unique solution. So this is also true. They are asking for not true. See, there is a unique point alpha beta on this line for which the system has infinitely many solutions. Now, when system can have infinitely many solutions, see, for infinitely many solution, alpha should be 0. Sorry, delta x should be 0, delta y should be 0, delta z should be 0. And at those points, delta should also be 0. So for unique solution, see, I'll do it here. For infinite solution, beta should be 11 by 4, alpha should be minus 25 by 2, beta should be 11 by 4, alpha should be minus 25 by 2. At these points, what is delta? Delta z is 8 beta minus 2 alpha. Just a moment. Yes, sorry. 8 beta minus 2 alpha. Minus 3. Thank you. 8 beta minus 2 alpha. Minus 3. So delta is going to be, so 2 beta is 11 by 2 minus alpha. Alpha is 25 by 2 minus 7. So 11 plus 20, 11 plus 25, 30, 4 by 2, 17 minus 7, that is 10, which is non-zero. So they are saying for unique point, there is a unique point alpha beta on this line for which the system has infinitely many solution. So for infinitely many solution, I need to have alpha minus 25 by 2 and beta 11 by 2. But that point does not lie on this delta. Mala, that point is not going to make delta 0. So this is false. For every alpha beta which is not equal to 7, 7, this line x minus 2y, x minus 2y plus 7, the system has infinitely many solution. Beta or beta. For every point, there is a unique point alpha beta on this line for which the system has infinitely many solution. Infinitely many solution. कोई calculation, some calculation error is what I'm making, I'm sure. कुछ तो issue है. Is there anything I'm doing correct? Please check once, everyone. Am I getting the right delta x, delta y, delta z? A and B are definitely true. There is a unique point alpha beta on this line for which the system has infinitely many solutions. For infinitely many solution, x plus 2y plus 18. Am I getting anywhere x plus 2y? D is definitely false. I'm very sure. D is false. There is a unique point alpha beta on this line for which the system has infinitely many solutions. For infinitely many solutions, delta x, delta y, delta z, and delta should be simultaneously 0. Let's do one thing. If I take a point, means x plus 2y plus 18 equals to 0. So that can be written as, since alpha beta satisfies this, alpha plus 2 beta plus 18 equals to 0, and 2 beta minus alpha minus 7 equal to 0. If I add both of them, 4 beta minus 11 equals to 0, so beta goes 11 by 4. Yes, इस पे ये 0 आ जाएगा. If I put beta as 11 by 4, alpha is minus 18 minus 11 by 2. Or I should say 2 beta minus 7. Beta is 11 by 4. Put the value of beta. Get alpha is 11 by 2 minus 7. 11 by 2 minus 7. So minus of 3 by 2. Correct? Alpha is minus 3 by 2. At those alpha beta, if I see delta z, that is going to be there's a problem with this delta y. Delta y is 1 time 9 minus 98 minus 6 times 3 alpha minus 7, 1 time 14 alpha minus 3. So 9 minus 98 minus 89 minus 18 alpha plus 42 plus 14 alpha minus 3. So minus 4 alpha, 42 minus 3, 39. Correct. Yes, so it's everything is correct. Minus 50 minus 4 alpha, so 2 alpha plus 25. So alpha is minus 3 by 2. चलो डेल्टा जेड देखें. If I see 8 beta minus 2 alpha minus 3. 8 beta is 22 minus 3 minus 3. 22 minus 3 minus 3. बस क्या हो गया? What happened? So I'll see it later on, but as of now, I think they both are false. Fine, rest. If I see something in this question, we'll talk about it in the next lecture. I cannot spend the whole day on this simple question. Now see this question. Let This is matrix A, certainly. That matrix A is this. So A is 2, 1, 0, 1, 2, minus 1, 0, minus 1, 2. They are asking for determinant of adjoint, of adjoint, of adjoint of 2A. Now, first of all, I told you as many number of adjoint are there. It is determinant of 2A raised to the power 2 raised to the power 3. If you remember when I told you if it is nth order matrix, it would be determinant of A to the power n minus 1 to the power k, where k is the number of times matrix is being repeated. So this is what? This is 2A determinant to the power 8. Am I correct? Am I correct? Now, this 2, since it is a 3 by 3 matrix, when this 2 will come out of the determinant, it will come as 2 cube. So it is 2 cube determinant of A whole to the power 8. Now let's find determinant of A. 2, 1, 0, 1, 2, minus 1, 0, minus 1, 2. 2 times 4 and 1, 5, minus 1 time 2. So it is 10 minus 2, 8. So determinant of A is 8. So it is 8 into 8 whole to the power 8. 8 into 8, 64. 2 to the power means 64 is what? 2 to the power 6, whole raised to the power 8. And they are telling me this is 16 to the power n. So 2 to the power 48 is 2 to the power 4n. Implies 4n is 48. So n goes 12. Tell me, is there anything which you did not get? Have a look. Even if you want, I can repeat the theorem again, but you have to tell me for that. The theorem is, see, I will repeat everything for a 3 by 3 matrix. Determinant of adjoint A is determinant of A square. Determinant of adjoint A is determinant of A to the power 2 to power 2. Determinant of adjoint of A, determinant of A to the power 2 to the power 3. So now if you repeat this adjoint n number of times, that means determinant of adjoint, and so on adjoint of A, that would be, say, determinant adjoint is repeated k times. So it will be determinant of A to the power 2 to the power k. Like here in this question, this adjoint is repeating 3 times. So that is why I have written determinant of A power 2 ki power 3. That is determinant of 2A to the power 8. And then it is fine, I think. Anybody, anything else? Clear?
Yes, sir, it is clear.
Sure. No. Have a look at this question. Same variety of question. Now I want correct answer from most of you. Please. Try it quickly. Yes, please. A be a 3 by 3 matrix and determinant of A is given as 2. A be a 3 by 3 matrix and determinant of A is given as 2. Now n is determinant of adjoint. See, now adjoint repeating 2024 10. N is what? That is adjoint of adjoint of A. Adjoint repeating how many times? 2024 times. Yes or no? So that would be what? Just I told you, determinant of A power 2 power 2024. Am I correct? That is 2 to the power 2 to the power 2024. Now they are asking when n is divided by 9 is equal to remainder. Remainder when n is divided. Now this is a new challenge for us. See, this 2 to the power, this 2 can be written as 8u to the power 2, sorry, 8 to the power 1 by 3 to the power 2 to the power 2024. That is 8 to the power 2 to the power 2024 upon 3. Yes or no? Now let us first of all analyze this. This power 2 to the power 2024, this 2 to the power 2024, this can be written as 3 minus 1 to the power 2024. So when divided by 3, when we divide it by 3, remainder is 1. Am I correct? Remainder will be minus 1 to the power 2024, which is 1. Means this number can be of 3k plus 1 time. Correct? This number is of 3k plus 1 time. So again, I will come back to this position, and this 2 to the power 2024. It can be written as 2 to the power 3k plus 1. That is 2 times 2 to the power 3k. 2 times 2 to the power 3 whole to the power k. That is 2 times 8 to the power k, correct? Which can be written as 2 times 9 minus 1 to the power k. Now there is a new challenge for me. When you divide 2 to the power 2024, this k is even or odd. The new challenge for me is this k, this is even or this is odd. Now see, if I do a binomial expansion for this, what do I get? 2024 C0 minus 2024 C1 into 3 plus 2024 C2 into 3 square and so on and so forth. Do you realize all these terms, even if I take 3 common, is going to be an even number ultimately? Yes or no? Here last term is going to be 2024 C 2023 3 raised to the power 2023 and last is going to be 2024 C 2024 3 raised to the power 2024. Okay, so all the terms are even except this as odd. So if I take 3 common, I will get an odd number. So this k is going to be an odd number. So since this k is an odd number, the remainder is going to be 2 into minus 1 raised to the power odd. That is minus 2. That is congruent to 6. So remainder is going to be 6. Have a look. Understood? Anybody? Sorry, remainder is minus 2. We are dividing by 9. Na? 9 means answer is 7. Tanush, you want me to explain it again? This one you are asking for? Tanush. Hello. Okay. Vidasri, can you tell me up to which point did you understand? Vidasri, you can switch on your mic and then tell me. I can explain as much as possible for me. Explain once again, Tejas. So, see, there are adjoint repeated 2024 times. So that is why answer is determinant of A power 2 power 2024. This is completely according to this theory which I have just told you. Fine. So it is determinant A given as 2 to the power 2024. So this processing that I have done this. Just to make you understand why I am looking for power in the form of 3k plus 1. That is why, because first of all, in the base, I want something close to 9. Either it should be 10 or it should be 8. So I have written base 2 as 8 to the power 1 by 3 whole raised power 2 to the power 2024. So it became 8 to the power 2 to the power 2024 upon 3. So first of all, I need to check how we can write it in the form of 3k plus 1. So this 2 to the power 2024, it is 3 minus 1 power 2024. So definitely a 3k plus 1, this is of 3k plus 1 type. Now one more thing, later on I realized I also need to check this k is even or odd. So what did I do? I expanded it in the binomial form, like 2024 C0 minus 2024 C1 into 3 plus 2024 C2 into 3 square and so on. Now see, this 2024 C0 is what? This is 1 minus, see 3 times. What are the term inside? 2024 C1 plus 2024 C2 into 3 minus 2024 C3 into 3 square and so on. Second last term will be 2024 C2023 3 raised to the power 2022 and last will be 3 raised to the power 2023. See, every term is even. This is even, this is even, this is even, this is even. Only this is odd. Means the quotient when I divide by 3 is going to be odd. That is why I have written 3k plus 1 where k is odd. Now, this again I came here. This can be written as 3k plus 1 where k is odd. So I split it 2 ki power 1 alag and 2 raised to the power 3k separate. 2 cube ko we can write 8 raised to the power k. It is 9 minus 1 to the power k. Now you use binomial expansion again here. So every term will have 1 except one term, that is minus 1 raised to the power k. So minus 1 raised to the power odd. This is your remainder including this 2. So what is the remainder now? Minus 2. Minus 2 remainder means remainder is 7. Now I think it is clear. Is it clear now? See, I understand it is a tough question and which does not only include the knowledge of determinant, but also include the knowledge of matrices and the knowledge of binomial theorem. And that is not a small knowledge, intense knowledge of binomial theorem. Well, to move forward, see this question. dk is 1 n n, 2k n square plus n plus 2 into n square plus n, 2k minus 1 n square and n square plus n plus 2. If you remember, we know when we add two determinants, we keep their two rows as it is. Yes or no? Two rows as it is, and we add them along their third row. So first of all, I'll do this. Sigma k from 1 to n dk. That is d1 plus d2 plus d3 and so on dn. Now see, its second and third rows are constant with respect to k because sigma is on k. So I'm not changing second and third row. Second as it is, third as it is. The first will be 1, 2, 1. Second as it is, third as it is. D2 will be 1, 4, 3. Second and third as it is. D3 will be 1, 6, 5. And so on till nth term. Yes or no? Now, at the first row will add. So 1 plus 1 plus 1 and so on 1. 2 plus 4 plus 6 and so on up to 2n. 1 plus 3 plus 5 up to 2n minus 1. Second row is n square plus n plus 2 and n square. Third is n square plus n and n square plus n plus 2. Am I correct? Now see, first row, first column, 1, 1, 1, n. This is n into n plus 1 means n square plus n. And this will be third element, sum of first n odd natural numbers. This will go n square. Then n square plus n plus 2, n square, n square plus n square plus n plus 2. This is what you got. Now to simplify this, I use an operation, write R2 as R2 minus R1. Also write R3 as R3 minus R1. R1 as it is n square plus n square. 0, 2, 0. Here it is 0, 0, n plus 2. And now if I expand it, what do you get? n times 2n plus 2, n times 2n plus 4. This is what you're getting. And they said this is equal to 6. And this is given to, sorry, 96. This is equals to 96. Means n into n plus 2 is 48. So that's pretty much obvious. N is 6. So that 6 into 8 is 48. So n is what? 6. Correct? Easy one. Anybody? Now, have a look at this question. Very easy question. Yes, please try. Matrix A is given, matrix B is given, C is A, B, A transpose. And X is what? X is A transpose C square A. That is A transpose. C square is A, B, A transpose, A, B, A transpose. C written 2 times into A. Got it? So determinant of X will be what? Determinant of A transpose, A, B, A transpose, A, B, A transpose into A. That is 3 times A transpose, A, 3 times A, and B, B, 2 times B. Correct. Now determinant of A transpose is equal to determinant of A. So determinant of A to the power 6, determinant of B square. Now what is determinant of A? Determinant of A is root 2 plus 1. Determinant of A is 3 and determinant of B is 1. So it is 3 to the power 6. That is 243. Very easy. Tell me, Mahesh Babu, understood?
Yes, sir.
Very good. Now go for this question. The value of alpha for which this is 0 lies in the interval. See, this is 1. This is 3 by 2. This is 2 alpha plus 3 upon 2. 1, 1 by 3, 3 alpha plus 1 upon 3. 2 alpha plus 3, 3 alpha plus 1, 0. This is 0. This one you can write as 2 by 2. This you can write as 3 by 3. So take 1 by 2 common from first row, 1 by 3 common from second row. So what do you have now? 2, 3, 2 alpha plus 3, 3, 1, 3 alpha plus 1, 2 alpha plus 3, 3 alpha plus 1, 0. That is 0. Now I use an operation. C1 को I write C1 minus alpha, sorry, C3 को लिखते हैं. C3 को I write C3 minus 2 times C3 को I write C3 minus alpha times C1 minus C2. Good. So C1 में no change, 2, 3, 2 alpha plus 3. C2 में no change, 3, 1, 3 alpha plus 1. C3 को, if you write C3 minus 2 times alpha minus 3, so it will become 0. This will also be 0. And this will become minus alpha times 2 alpha plus 3 minus 3 alpha plus 1. Now this is 0. Now if you expand it, you will get minus alpha times 2 alpha plus 3 minus 3 alpha plus 1 goes 0. Make this minus as positive. So it is 2 alpha square plus 3 alpha plus 1 equal to 0. So it is 2 alpha square plus 6 alpha plus 1 equals to 0. Now options you see. Let us assume some f of alpha. 2 alpha square plus 6 alpha plus 1. Fine. Check for the first option. In minus 2 comma 1. How about f of minus 2 into f of 1? F of minus 2 is going to be 8 plus 1 minus 12. And f of 1 is 2 plus 6 plus 1. That is negative. Means that alpha lies in, means one root of this equation that lies in minus 2 to 1. So minus 2, this is correct. Rest, no other option will come correct. F of minus 3, you will check minus 3 f of into f of 0 positive, f of 0 into f of 3 positive, f of minus 3 by 2 into 3 by 2 will also come positive. So this is the only option. So what theorem did I use? That for a continuous curve, if f alpha into f beta goes less than 0, that means at least one root of fx equals to 0 lies in alpha to beta. Understood? Am I clear? Hello? Mahesh Babu, understood?
Not clearly, sir.
Where did you stuck up?
That C3 there.
C3, that's simply an operation on determinant. Means directly you will expand, you will get long expressions. I have used a property. I use C3 as C3 minus alpha C1 minus C2. So that I can make two elements 0. And once two element is 0, it's a win-win situation for us. Understood? So with this, I have been able to expand the determinant and get the quadratic in alpha. Fine. Well, this is all. So we have done 5 to 6 questions today, which have been there in previous year JEE mains. So you see, there's no single question which is completely on determinant or matrices. Every question is a blend of somewhere they included PNC, somewhere they included quadratic equation concepts, somewhere they included binomial concepts. So this do happen. All right. So you have to be very cautious while going for JEE mains and advanced these days. So we have to be multi-conceptual. We should be able to handle multi-concepts altogether. Fine. Anyways, that would be all. You start practicing determinant matrices. Try to complete your NCERT. That's very easy. So make sure you complete it thoroughly. And tomorrow again, we will have some more questions. All right.